In this example, we have somebody's amount of miles ran over a certain period of time. So knowing that information, the question says, find the slope of the graph and the point of the unit rate. Okay, so this is asking us to find three things actually. We need to find the slope, the point of the unit rate, and then we need to know the unit rate before we can even find the point of the unit rate. So what exactly even is this unit rate? I wrote the definition right here. If you want to go ahead and jot it down, I'm going to explain it in a second, but for now, we're going to find the slope. Find the slope. I showed us in the last video, there's a couple ways we can do this when we have a graph. Today we're going to do it the more technical format with the y2 minus y1 over x2 minus x1 format. We need to find the coordinate points in order to do that. So here we have 1, 2, and then at our other point we see it's at 2, 4. Let's go ahead and plug these values into our formula. 4 minus 2 over 2 minus 1 gives us 2 over 1, which is a slope of 2. If you want to see me go more in depth on that, simply just watch the video. I have a couple videos below, and it'll explain everything about finding slopes. Or we could also count rise over run, whatever you prefer, whichever is easiest. Now we need to find the unit rate. What is this unit rate thing that we're talking about? It says rate of change over a quantity of 1. Now, to me, that makes absolutely no sense whatsoever when I first read it. So if it makes sense to you right away, then congratulations, you're smarter than me or probably than everybody else for that matter. But since I don't think that definition makes much sense, I'm going to explain this to us. And it's funny because that's the definition in my own words. So anyway, over a quantity of 1. So right here we have a little fraction bar, and I'm going to put the 1 under it because we know there's going to be something over the quantity of 1. Okay, let's say you got in the car and you drove 60 miles in 1 hour. 60 mph. If you drove 60 miles per hour, how many miles did you drive in 1 hour? Seems pretty easy, right? It's just 1. Okay, so this part right here would be a perfect unit rate. The unit rate would just be 60. So how do we apply this information to our graph? We know that we need something over a quantity of 1. And in the car example, this 1 represents the amount of time in hours. So why don't we do that exact same thing with our graph and have it represent the time? And fortunately, we see time on our x-axis. So what do we need to do now? We know that if we went 60 miles in 1 hour, that means at 1 hour, 60 miles were driven. Okay, so if we look at 1 hour on our chart right here, what else do we know? Let's go up. Let me change the color a little bit. Let's go up and see what happens. We intersect at the point 2. So let's go ahead and write that 2 there. And this 2 over 1 is our unit rate. That's exactly how we find it. And then I'll show you how to do it if you're not given a quantity over 1 in the next example. Unfortunately, we're not done with this problem because we still have to find the point of the unit rate. Okay. How do we do that now? Fortunately, we already know what our unit rate is, so now we have to find the point of the unit rate. Literally, that just means tell me where you found the unit rate. So just how we did maybe 1 minute ago or so, we went on our graph, looked at the x-axis, and asked ourselves, where is the 1 and what happens at 1? At 1, we see it intersects with a 2. So we found that unit rate at the point 1, 2. It's as simple as that, and now let's move on to the next example. Every 2 minutes, 5 students subscribe to the Mathaholics. Find the unit rate of this proportional relationship. Wow, how much I wish that was true, but who knows? Maybe one of you guys can help me make that true. So let's speak it into existence, right? Okay, so we're not going to be able to solve this the exact same way as the last one because we don't have a graph. But that's okay because we know exactly how to find slopes and unit rates. Sorry, we know how to find slopes from tables and from equations. So we're going to be able to find a unit rate really easily. Let's go ahead and draw our table. And let's see if maybe one day I can draw a straight line. Okay, well today is not that day, so it's okay. Here's going to be time, and here's going to be students. Stud is short for students because you guys are studs. Time goes by 2 minutes, 2, 4, 6, 8, and 10, and then students goes by 5. So here's 5, 10, 15, 20, and 25. Now, how on earth are we going to be able to find this unit rate? Well, the first thing we're going to have to do is take care of the slope. Slope is simply y over x, or we can subtract two y values from each other to see what we get. Let's work with these right here. 15 minus 10 gives us 5. 6 minus 4 is going to give us 2. And as you can see, that would be the exact same thing we'd get if we just used this first row up here. So our slope is 5 halves. I'm going to go ahead and write slope. Remember, m is for slope, believe it or not. Slope is 5 halves. Perfect. Now, remember our definition for unit rate. I'm going to go ahead and write it again. It's rate of change over a quantity of 1. This right here is our definition for unit rate. So as you might be able to tell, we already have an issue. We see a rate of change right here, but this is over a quantity of 2. So how on earth are we going to be able to solve this problem? If I say, well, that was a mistake, but let's write it again. If I say I get 3 pizzas for every $1 that I spend, how many pizzas do I get for every $7 that I spend? We would set it up as a proportion just like that, and then we would cross multiply. So that is the exact same thing we're going to do in this situation. We're just going to set up a proportion and cross multiply. What is the first term we're going to use? We're going to use this 5 halves. So I'm going to write it over here. And I guess if I had $1 for every ugly number I wrote, we'd all be rich. Equals, how am I going to set up this proportion? We know that we need something over a quantity of 1. So for sure we're going to need to have a 1 down there. And then we need something, and we don't know what that something is, so I'm going to go ahead and make that our x. And now all we have to do is cross multiply. In case you don't remember how to cross multiply, I'm going to do a very quick overview. We multiply straight across, so the 2 and the x, and then the 5 and the 1. 2 times x is going to give us 2x. 5 times 1 is going to give us 5. We want to isolate for that x, divide by 2, and then as we can see here, our x is equal to 5 halves. Now, if you did it right, your unit rate should be equal to your slope, and that's something that we also saw in our first example. Let's try one more example and see, just for the practice of it. Okay, and I'm just gonna make this up off the top of my head. Let's say every 1 minute, 10 students subscribe to Mathaholics. Find the unit rate of this proportional relationship. I encourage you to pause the video and try it out on your own. And if you get the right answer, leave a comment down below. The first person I see who gets the right answer is going to get a free Cane's gift card sent to them pretty much immediately. So it helps to be good at math sometimes. Every 1 minute, how many intervals do we increase by? Just by 1. So 1, 2, 3, 4, 5, and so on. 10 students subscribe. 10, 20, 30, 40, 50. What's the first thing we do? We need to find our slope. Let's go ahead and do that. Let's say we're going to take these quantities. 30 minus 20 is going to give us 10. And then 3 minus 2 is going to give us 1. And once again, if we just did y over x, we would have gotten the exact same thing. But just for the purpose of doing it the technical way, I guess. Our slope is 10. M equals 10. And then what do we do in order to find the unit rate now? We tell ourselves, okay, rate of change over 1. And like I said, I just made this problem up over the top of my head, so I did not realize that the slope was just 10 over 1, but that is also going to be the unit rate. So I hope this problem was easy for you guys, and if so, let me know, and if it wasn't, let me know how I can help you out. Thank you, and I hope you learned something.